Okay, so we're going to continue on in chapter 10. I didn't get very far into it last time. Then I went off and created my own class based upon rectangle. But there's some interesting information in here that you should be aware of. It says, as we learned in the previous chapter, an object is a collection of data that provides a set of methods. For example, a string is a collection of characters that provides methods like character at and substring. A lot of what you've been doing already, you've been using objects over and over. In NetBeans, yeah, get that out of the way. Just from the very start, when we're declaring a public class, we're working with object-oriented technology. And part of this is not only working with it, but also using more advanced features of objects like inheritance. And we'll talk more as the semester goes on, like what does this extends mean and so forth. Here's new frame. Here's public new frame. When that name matches and there's nothing in between public and this name, this is our constructor here. So a constructor can itself call another method. Here's an event that we programmed, and an event inherits a lot of the code from other object-oriented topics, and we're going to see that. Can't say they're all just strictly objects, because it's a little bit more than that. And all of these are J buttons. So all those are J buttons. I don't know if it'll let me go to the anything where I can view it. Maybe not. But when you add a button on there, you can add 1,000 buttons. Each button is an instance of a J button. So you've been using that concept over and over already. Talked a little bit about the point last time, what that represents, and so forth. Talked about the attributes. Those are your variables you declare. Talked about how you can access them directly if they're declared publicly. You refer to the .x and .y. I think the point also had a get, if I remember right, a get option on it. You can pass objects as parameters, and we saw that. I passed in a fraction object into a method last time. And I know it got kind of hairy with that fraction example, but what I was trying to point out is some of these options in here where you can pass in an object as a parameter. Now this opens up so much because when you when you pass in an object, you could be passing in 50 variables. You can have 50 attributes, class variables defined. When you return a value, unfortunately, our standard return only returns one value. If you needed to return two values, like if you're programming the quadratic formula, you could return, instead of returning a string with two values separated by a comma or something, figure out how to separate it. You can have an object defined with your answers, and you return that object, and it returns both answers. So a lot of flexibility when you're dealing with an object. Again, as our import, remember this is how you create a new instance with a new. So you have your class name definition here, whatever you want to call it here, and then the same name on this side as is right here, and then your parameters if necessary. Um, okay. This returns your x position of your rectangle. And then if you take your width, divide by 2, that'll take you halfway over. Okay. If you take your height, divide by 2, then that'll take you halfway over. So that's how you can get the center of the box. Now notice what's being returned is a point. And what's being passed in is a rectangle. So when you're working with objects, you have to really think beyond just single values. Excuse me. We have mutable objects. You can change the contents of an object by making an assignment to one of its attributes. For example, to move a rectangle without changing its size, you can modify the x and y values. And that's what we see here with the box.x and box.y. And that'll change those. We can encapsulate this code in a method and generalize it to move the rectangle by any amount. So we have our move rectangle here, and okay, yeah, that. So we pass in rectangle box, and then the dx, dy, change in x, change in y. What threw me for a minute is passing this in, but I forgot this wasn't the rectangle that I created, the class. This is the default one that comes with Java. If we had the default one I created, you would not need to pass in the rectangle box. The fact that it's a method that's contained within that class, then just referring to this dot x, this dot y, we'd be accessing the x and y of that rectangle directly. Let's see. Java provides a number of methods operating on points and rectangles. For example, translate has the same effect as move rectangle. But instead of passing rectangles an argument, you use the dot notation, box.translate. This example is a good illustration of object-oriented programming. Rather than writing methods like move rectangle that modify one or more parameters, we apply methods to objects themselves using the dot notation. And that's what I was talking about. Here, we do not refer to the object. The fact that we create an instance called box and then do a dot translate, then by default, it knows which one is in. Hold on a second. Aliasing. When you assign an object to a variable, you're assigning a reference to an object. It's possible that multiple variables refer to the same object. Usually those are referred to as instances. When we create an instance here and set equal to a new rectangle, but this instance here, when we come down here, this right here gives it another name we can refer to it. Box 2 is equal to box 1. They're aliases for the same object, so any changes that affect one variable also affects the other. It's not exactly the same idea as both being brand new instances. One's an instance. Let's see. 50 to all 4 sides. I never really have used this hardly at all, if maybe one time or two in a programming class. Usually I don't use aliases. Probably it's best to use, as far as I can envision, is that if you are referring to an object that's kind of generically defined, and you want to specifically give it a name that's meaningful to that segment of code. Well, that's pretty vague. But if you had a Amazon object, and again, this is just kind of a off the cuff type of explanation, but it has a description. That's one of your attributes, class variables. It has a quantity, has a cost, let's say. Well, we get down to the books. And if we're creating just in general a new Amazon object, maybe we want to create a reference to Amazon books. And that Amazon books is going to tie back to my original Amazon object. In the DVD section of Amazon, you can have Amazon DVD, which again refers back to our Amazon object. They're all the same here, but referring to the Amazon object, the Amazon books, and maybe that books section, maybe makes the coding a little bit easier to understand. That's perhaps one purpose. Now, when you create an object variable, remember you are storing a reference to an object. In Java, this keyword null is a special value that means no object. You can declare and initialize object variables this way. Point and then blank is equal to null. So the variable null is represented in the state diagram by a small box with no arrows, as you see there. State diagram is not like screen design. That's just referencing what are the values. Here I said equal to null. Null is not the same as empty, so don't think that. Although some programming languages do kind of merge the two together. When it's equal to null, oftentimes you cannot do any kind of calculation with it. You cannot do any kind of manipulation until you set it equal to a value. Some programming languages default it to 0 if you don't specify. Some will default to null. Now here we're specifically saying it's equal to null. And then down here I say int x equals blank dot x. So it's trying to retrieve the value of blank dot x, but since blank is null, it gives a null pointer exception. Now here we want to do blank dot translate, and let me think about this one. Okay, I guess the idea there is that you're actually moving it, and well, if it's set it equal to null, it doesn't even exist. Think about that one, why that would give an error. On the other hand, it's illegal to pass null references as an argument or receive one as a return value. For example, null is often used to represent a special condition or indicate an error. Now we got garbage collection, and there's different areas where you'll see garbage collection detect or talked about in programming. In section 10.6, we saw what happens when more than one variable refers to the same object. What happens when no variables refer to an object? This first line creates a new point object and makes blank refer to it. Okay. Second line changes blank, so instead of referring to the object, it refers to nothing. In a state diagram, remove the arrows between them, as in this figure. If there are no references to an object, there's no way to access its attributes or invoke a method on it. From a programmer's view, it ceases to exist, however, still present in the computer's memory, taking up space. So this is picking up a segment of the memory and assigning values to it. When you set it equal to null, those values are still in your memory. So, that's the idea. How do you free that back up to give it back to the computer? As your program runs, the system automatically looks for stranded objects and reclaims them. Then the space can be used for new objects. This process is called garbage collection. You don't have to do anything to make garbage collection happen. In general, you don't have to be aware of it. But in high performance applications, you may notice a slight delay every now and then when Java reclaims space from discarded objects. Not all programming languages have garbage collection built in. Some of them you have to do the garbage collection yourself. Some of them you have to program correctly. And instead of just setting it equal to null, you have to, again, give back the memory you no longer using from those variables or objects. That was a big thing about C++, is how it was supposed to make the garbage collection so much easier from memory. C didn't really do that great of a job of it, and C++ was supposed to be the fix for that. Haven't written up to actually tell you if it worked, or worked effectively, I should say. Okay. What we're learning so far, point and rectangle objects each have own attributes and methods. And we saw that with our last 2 days of examples. We declared a rectangle in one case, and we referred to attributes, its variables or class variables. And I think we had width and height or length. I forget which length I think it was. And then we had methods that we declared. One we calculate the area. We take width times the length. And then I think we did perimeter too. Attributes are an object's data, and methods are an object's code. That's just kind of what we indicated here. For the point, we have X and Y, and then you might have methods that you call. Here's point X, Y. This might be our constructor. We have a toString. That'll convert whatever to a string. Over here, the rectangle, we had X, Y, width, and height. I didn't have an X, Y in mine, but you can have a constructor. That's what this first one is. A toString converts it to a string. Row. I assume that means just grow up by so many numbers, like by 5 or 7 or so forth. I wouldn't think it'd be percent because this is an integer. And although you could say 50%, 70%, if you wanted to grow by 50.2%, then you couldn't use the integers. Then our translate. Now, in practice, it's more convenient to look at high-level pictures than to examine the source code. And this Unified Modeling Language, UML, defines a standard way to summarize the design of a class. So this gives you a UML class diagram. You see this in different forms when you look up documentation. Some of it's a little bit more verbose than this. You have a little bit more explanation. Some might be even worse than this. Okay, class diagram is divided in two sections. The top half lists the attributes, the variables, class variables. The bottom half lists the methods. It says UML uses language independent formats. Rather than showing INTX, the diagram uses X:INT. Some people really are into UML. You see, there's a whole site here dedicated to UML. Remember, you can become a member of this. I guess go to training on UML. I won't say it's not important, but I really haven't used it very much. Besides a little bit you see in books here. This would be somebody that's maybe creating system libraries that really benefit from this. Somebody that's creating code that they want to put out there for other programmers to use, maybe in an open source type environment. Maybe UML would be appropriate there. For example, a programmer at IFR, we had a way to access the Oracle database. And every program we wrote, we put in that code to access the Oracle database. Well, if we had 50 programs we wrote between all the programmers, if for some reason Oracle changed it slightly and we needed to sign on in a different way, different parameter or whatever, what we'd have to do is we'd have to check out those 50 programs and put that change in all 50 programs. Now, us making that change 50 times, if we edit, copy, and edit paste, probably not a huge deal there. But what if we leave out a line of code? Put an extra line of code in there. Then that doesn't work very well. So we could create an object for a login, like a login object. And that's what he did. He created a login object that was a separate piece of code. And then whenever we wanted to log in Oracle database, we used that object, we created an instance of it, and signed in. Very clever piece of work he did. I don't think I probably would have thought of it. He was a sharp programmer. His skill level is probably about 10 times my level. He's something else. He could write a program faster than you could ever imagine. I'm trying to remember what different methods he had for it. But this would be the place where you could document that so that if somebody were to use his code, they would see what methods, what public methods he created that you could then call. So it's kind of a documentation piece. Now, Java library source. Throughout this book, you've used classes from the Java library, including system, string, scanner, math, random, and others. Now, notice what I've been saying here. We have used classes from the Java library, including those. So again, you've been working with classes for quite a while now. Says you may not realize these classes are written in Java. In fact, you can take a look at the source code, see how they work. Under Windows, it's likely under C:\program files Java. Let's see. And JDK Java Development Kit. Okay, I didn't say which one it's in, so let me guess. Library. Maybe not. Source.zip. Okay. So come up here, type source.zip. There it is. I'm going to copy that. Come over and paste it somewhere so I don't. Documents or downloads where I usually put stuff because I just routinely clear out downloads. So I put nothing important in there. I right clicked on it to choose extract. And click it, yeah, it. 8,204 items. I did receive the they met about to schedule yesterday. So I did hear back from them, and relatively few changes. I was shocked. For the most part, what I came up with, my second attempt, they liked. So you should see those computer science courses be out there for fairly soon. I was working on it kind of late last night, and I worked on it a little bit this morning, and just trying to figure out how to fit everything in. Actually, I guess while that's clunking away, I could show you. Oh, this one. Um, they they thought that I should add in an introduction to digital design, and which is probably good because I really need to teach that every semester until I get my skills increased on that because I got a ways to go on that. I'm understanding more and more of it each time I teach it, but I think that teaching it twice a year, I think my skill level will increase quite a bit on that. Um, they didn't think I should offer GIS development, so I kind of moved that over on the side. But then they thought I should either offer Java or Introduction to SQL again. And so I'm leaning, I'm still trying to think about that, but I'm leaning to Introduction to SQL. Anyway, that's kind of like I say, I'll have it finalized today. I'll iron out the other pieces to it and see. Still going. I'm real curious myself. I never have looked in this file. Um, but I'm real curious myself because sometimes the code that's written in these programs, these objects and so forth, are not really very written very well. Some of them are very difficult to follow. Okay, let's see. Okay, here's checkbox.java. I'm going to right click on that and choose open with WordPad. Notice here, um, they give a lot of documentation, don't they? Okay, so we get down to here, start getting into our code. A lot more documentation. This doesn't look too bad, actually. Some of what I've looked at hasn't the names that they've given it haven't been very meaningful. Like use single letter names and so forth. This is especially true in some of the Linux libraries. It's written in C. Um, if you ever get a chance, you download those, and being able to change them is kind of a challenge when it isn't documented well. Well, this has got so much documentation, you'd be hard pressed to not understand it. Anyway, that's a code that's out there. Let's see. Open a different one, but same idea. It says, notice how much a point.java is documentation. Each method is thoroughly commented, including the at parameter, at return, and other Java doc tags. Again, the Java doc allows you to bring in those comments into like the NetBeans, so you can read more about it. Okay, vocabulary. Oh, the dot note attribute, one of the name data item, make up an object. The dot notation. You see this reference in a lot of different places. Um, most of your popular programming languages use a dot notation in some form. Uh, this dot transform. Um, system dot out. So it's a way of kind of relating two items together. One might be a hierarchical relationship where this, and then you have this and this. So one's underneath each other. Some cases may refer to object's attribute, or like it says, a method. Object-oriented is a way of organizing code and data in objects rather than independent methods. So you generically define something, and then you create instances of that generic definition. Garbage collection means a lot of different things, but specifically what they talked about is giving back memory space. How about garbage collection on like a hard drive? Do you think that's necessary? It should be, but maybe it's done in a little bit different way. If you have pointers to where segments or partitions may be done, if you have pointers to where the files are stored, if you just destroy the pointers and say that that kind of, in some cases, says that memory is not free for you to use. Um, us leaving bits and pieces of information out in memory on your computer, RAM, is not the problem. The problem is us not telling Windows or whatever operating system you're dealing with that, hey, that memory is now available. Does that make sense? Then we just, yeah, when you write new memory out there, it just overwrites what's there. So us having the data there is not the issue. It's the pointer, the reference, that's the real issue. And that's what some programming like just does not do a good job of. It does not go back to Windows and says, okay, this segment of memory right here, I'm done with it. Or even perhaps itself. So if it's a large enough program, it has a memory there, and then when it's done with it, returns that memory back to the program that's running it. So it could be two different ways. Used to be they didn't have that, and some of you have heard this, and I'm old, I repeat myself. But used to be Excel wasn't written correctly, and this was probably about 15 years ago. That version of Excel that was out then, and I'm thinking they fixed it. I really never have tested that. Um, but if you went in and out of Excel all day long, it would not free up all that memory back to Windows. So as the day went on, more and more of your RAM got consumed, and your machine became slower and slower. When I worked on the help desk at IFR, we'd receive phone calls in the afternoon, and it'd be a manager calling or accountant or something that'd say, "I think something's wrong with my computer. It's been going slower and slower all day long." Well, we knew exactly what the issue was. We'd say, "Well, reboot your PC, and I'll fix it," because rebooting it gives back that memory to Windows and so forth. So Excel would grab this chunk of memory and start using it. And then when you exit out, it did not return that back to Windows. So Windows didn't know any better. It said, well, okay, well, that's still being used. So that was the issue. I don't know if I could actually find anything on that. We'll see. I'm sure they've fixed it by now. Does Excel return memory to the operating system? Why is memory leak so bad in Excel? This is back in 2018. I seldom run out of memory, and when I do get a message I have run out of memory, I can either relaunch Excel, reboot the computer, make some to overcome the issue. List of known memory leaks isn't that large. Excel only recalculates the formula it needs to. Okay, since 80s increase. Now, assuming this person's right, and then they're talking about memory leaks here and so forth. Like I say, I haven't confirmed this myself. I haven't worked in the help desk in 15 years. But the fact that he's saying that he gets run out of memory, and he either relaunches Excel, reboots the computer. Rebooting the computer means it's not memory's not being returned back to Windows. Um, does that mean that they got Excel right yet? They don't, do they? Here you got what should be the top programmers of the world working at Microsoft, and that might be a joke to some people, but you have top programmers working there, and they cannot write a Windows program correctly, so it returns the memory. This is why if you can come up with a language like Java that does that garbage collection and handles returning the memory and so forth, so you don't have to reboot your PC, then that's a pretty powerful feature of a programming language. Because I guarantee my programming skills are not at the same level as Microsoft's programmers. So anyway, something to keep in mind on that. If you're using a programming language, whatever it is, and you hear this issue where the machine gets slower and slower, or tells them it's out of memory, and they have to reboot to fix it, then that means that that package isn't handling the memory correctly. Hmm. Excel memory leaks. Um, Reboot. This is what I was talking about. Memory leaks occur when a program, Excel, VBA, can obtain some memory but fails to hand it back to the memory manager. Um, Usually, you only notice this if you monitor memory closely or you run out of memory. Lately, and I don't know why it is, but sometimes my video recording doesn't work. Sometimes I forget because I'm getting old. But most of the time, when it doesn't work, it's not because I forgot, but it's because it bombs off for some reason. So I made a habit of restarting my computer fairly often because I'm figuring something's not giving that memory back, and it's a memory issue. That's the only thing I think of because it's not check the hard drive. I don't see any errors. The speed of it seems fairly good at that even at that time. I'm not out of hard disk space, so I figured it has to maybe do with something with the memory, and so I'm restarting it. And I told this to one. I might have told it to Kyle. I don't remember, but Windows 10. I was talking with our IT person. He was over here working on computers, and I just stopped in and say hi and BS a little bit. I didn't have any questions or problems. And he was telling me that Windows 10 he was reading, if you do a shutdown and then turn your computer back on, that will not free up the memory. Um, a shutdown just kind of saves the state of everything, and then shuts the computer off and so forth. And so when you push the button, it immediately returns the memory and the state of everything back to where it was and quickly comes up. When you restart, that's when it actually clears up the memory and gives the memory back. So if you do a nightly shutdown on your Windows 10 machine, and then you push the button, turn it on, thinking each day I got a brand new machine, well, not necessarily. Which is interesting when you think about it, because a lot of people do shut down, and so you got a whole slew of Windows 10 users at home that are just religiously shutting down their computer every night and then turning back on, and any memory that's been consumed by an application is still consumed that hasn't been given back. Um, Helps you explain why maybe people have so much difficulty. To me, that's a real serious design flaw in Windows 10, but they consider it a feature. Anyway, here's a partial list of things that can cause memory leaks. Page setup in Windows 95, Windows 98. Okay. Printing using HP printers. Uh-oh. I print with HP printers all the time. Recreating an Excel worksheet, replacing external link formula, some external data retrieval actions, controls embedded on worksheets, user-defined functions, and they're talking specifically about Excel here. Looks like inserting and deleting graphic objects such as bitmaps or JPEGs, not destroying objects in VBA by setting object variables to nothing. Remember the null we referred to? I'm assuming that's what they're talking about. I don't think I've really ever used objects in VBA directly. Okay. In theory, this is not necessary, but sometimes problems occur when this is not done, which means they don't have the program right. They haven't written it correctly. Excel's undo feature does not have a memory leak, but will use up memory that could otherwise be used for formula. Anyway. Question is, they got Java correct? Does Java have memory leaks? Competent JVM has no memory leaks, but more memory can be used than is needed. Because not all unused objects have been garbage collected, yet also Java apps themselves can hold references to objects they no longer need, and this can result in a memory leak. I don't worry about this. I don't sit there and lose sleep about whether a package has memory leaks, because I program in Windows. It's got too much memory anyway that you'd be hard pressed to probably, unless you shut down your computer all the time, you'd be hard pressed to run across an issue with that. You probably won't even notice the memory leaks. If you're programming for a smaller device, you've seen this example, or some of you have. I'm programming for that. Not that you can run Java on this, but if you're programming for this, memory leak here could be a serious issue because it's not returning whatever memory it needs. So I think all this operates off as voltage. Okay, enough of that chapter. And I'm not going to sign any of the projects on there. Chapter 11, classes. Whenever you define a new class, which we've done, we created that rectangle class. You also create a new type with the same name. So when we defined hello, we created a type named hello. We didn't declare any variables with the type hello. We didn't use a new object to create a hello object. It wouldn't have done much if we had, but we could have. Okay, so this talks about defining classes that represent useful object types. Okay, here are the most important ideas. Defining a class creates a new object type of the same name. Every object belongs to the same object type that is an instance of some class. Class definition is like a template for objects. It specifies what attributes the objects have and what methods can operate on them. The new operator instantiates, creates an instance of an object. Think of a class like a blueprint for a house. You can use the same blueprint to build any number of houses. And this is really relevant nowadays. My friend lives in a neighborhood in Wichita, and every once in a while I go to pick his son up, and my son and his son go to the movies and so forth. And where he lives are really beautiful houses, but they all look alike. I can easily tell where his house is because he's got a fence there. Most of them don't even have that fence there. And they're same color, same build. The only thing that's different on most of them is the number, and I suppose the where you are in terms of from the start of the community to that. They do that on purpose. They have this general design, and they allow some changes on the exterior, but for the most part, they want them all to look alike. And they allow some changes inside. But by using this object-oriented concept for building, then they can easily put up new houses. The building them is super easy. I'm assuming the same color is so that they can buy things in bulk that that color, that siding, so forth, and save money. I'm guessing. Yeah, that everybody wants to live in a house that looks the same. Um, but I had a person, individual in one of my algebra classes one time, and he worked at, I think, at EB Construction, and I was talking about the Pythagorean theorem, the right triangle, how you can use that to create a sharp corner. And I made a reference to in class, since I knew he worked there. I said, you've probably seen this over the years at in construction, where they can use the 3, 4, 5, or there's another one. I don't remember the numbering, but there's another standard one, which means if you have 3 feet on this side, 4 feet on this side, if you measure the distance there, that should be 5 feet. And if you got that, then it's a sharp corner, so a right angle. And he looked at me. He says, "We don't build things from scratch anymore." He said, "We rarely cut anything on site." He says, "It comes pre-cut. All we do is assemble." And that's the idea. They can save money that way, hire less people, have a better quality, because you don't have somebody building a house that doesn't know what they're doing, that can't do sharp 90-degree angles. Okay, methods that operate an object type are defined in the class for that object. Now here's a time class. It says one common reason to define a new class is to encapsulate related data and objects that can be treated as a single unit. We created a rectangle where we had width and length in there. If you create a polynomial in math, so you have a class called polynomial. If you haven't had algebra yet, polynomial is like x squared plus 3x minus 5 and so forth. Well, a polynomial has a number of terms. It has a degree. You could even have a leading coefficient. Could have an array, perhaps, of coefficients to represent the numbers that are in front of x to each power. So you could have a lot of different items. So they're related. That way we can use objects as parameters and return values rather than passing and returning multiple values. That's what I was talking about. When you're returning a value from a method, you can only return one. But if you return an object, an instance of the object, then you might be returning 50 variables. Okay, talk about point and rectangle. Another example, which we will implement ourselves, is time, which represents the time of day. So you see they got public class time and have hour, minute, and second designed. Okay, so if I bring this one up here, this is just one I was working with before. And I think you should be able to do this in a GUI form. We'll see. I do a right click on that, choose new, choose Java class, and call that time. And then click finish. And private integer, hour, private integer minute, and private double seconds. Second. So these are our variables we're declared, our class variables, class attributes, are called by different names in different languages. But those are going to be what's specific to this time object. Private means you can't access it, like over here. If I went back to my new frame.java, Okay, that is correct one. And I click this run right here. And I'm not in Visual Studio. Right click on it and go to events and quickly go to mouse clicked. And down here, you see I declare a time t. But if I do t or t equals new time, create an instance of it. And if I do t dot, nowhere do you see those three attributes that I declared. That's because I declared them as private. Probably where they're headed is they're going to use gets and sets to work with them. Okay, so instance are private, can be only accessed from inside the time class. If you try to read or write them from another class, you will get a compiler error. Private instance variables help keep classes isolated from another so that changes in one class won't require changes in other classes. It also simplifies what other programmers need to understand in order to use your classes. This kind of isolation is called information hiding. We've talked about that before. I give my my wife instructions on doing certain things on the computer, and I try not to give her too many instructions because she's not real computer literate, and it just throws her. And so I try to hide all that information. And so I very concisely will tell her to do this, this, and this. Really, no explanation. That's my interface for her to do. She tries to give me too much information when she tells me to do something. She wants to be very thorough, and she's good at it. All that extra information just confuses me, though. I'd rather just be told to do this one item here, and I don't need to worry about theory behind it, why it occurs, what it does in the background. I just want to do this. That's the idea of that hiding. Now you can have constructors. Now constructors, as we saw, is where you do the public and then you do like time. So it's still public because you need to access it outside of it. And then the name of your class matches the name of the constructor. And in this one, I don't have any parameters coming in. Now you might say, well, wait a minute. You already created a new instance over here and it didn't give you an error. Yeah, it didn't. Because Java has a default constructor that you don't even have to declare. Now over here in our constructor, which creates an instance, we can put whatever code we want. Theirs, they want us to set them equal to 0. So you see how they say this dot hour, this dot minute, this dot second? You don't have to say that. You could simply say hour is equal to 0. But since we're going to have a mixture later on of bringing in like parameters, perhaps called hour, it helps to say this dot hour, even though it's not necessary. The this refers to that particular object or instance of that object. This dot minute is equal to 0. And by the way, this dot, that pops up. Notice how now I can see second. Since I'm actually in the time class and I've declared it as private, I can access it just fine here. It had 0.0 since it's a double. Although you'll find putting a 0 there works fine too. They're putting a 0.0 there just to really emphasize to the reader that it's a double. Double is a number with decimals. Okay, this is a keyword refers to the object we're creating. Common error when writing constructors, put a return statement at the end. It's not actually returning anything. You're just creating an instance. And then they put it in one line here to create a time object. You must use time, little t for time equals new time. And that's oftentimes a convention you see in programming. I don't like it, and I don't use it. Because they'll like to put like time like that. Big T refers to the object, to the class. Little t refers to your instance name. Well, I find students get confused by time equals new time, time all over the place. So I try to always give that a different name, even if it's T. Now at this point, when we call this, invoke it as they say, it's going to create an instance and set hour, minute, and second to zeros. And it shows a state diagram. You got your time over here, little t, and I got hours, minutes, and seconds as your class attributes, class variables. Those you cannot have in your constructor, you cannot have the new statement. The new actually goes in wherever you create it. In our case, we created an instance over here. So it should not actually, the new should not actually be in the class, at least for that class. If you're using other classes within this, then yes, potentially. Now you can overload. Sure. They don't refer to it, unfortunately, but it's called overloading. And you can have other constructors by the same name. So public time, and you can just pass in hour, for example. So then you say this dot hour is equal to hour. This refers to your instance you have created of the object. Dot hour is that attribute, that class variable. The hour over here is a parameter you're passing it. If that throws you to have hour equals hour like that, put a p underscore in front of it like that for parameter. P underscore like that. So if that throws you to have them the same, then make the parameter always start with a P. Doesn't throw me, so I'm going to get rid of that. Now I didn't pass in this constructor. I didn't pass in minutes and seconds, so I'm going to say this dot minute is equal to 0. This dot second is equal to 0.0. Can I have a constructor where I'm passing in hour, minute, second. Then I'll say this dot hour is equal to hour. This dot minute is equal to minute. This dot second is equal to second. Public time, I could pass in a string. Now, if you're wondering, well, what do you mean a string? Why would you pass in a string? Well, what if my hour was of this form? Where the 10 represented the hour, 30 represented the minute, and 27 represented the second. Then I could use my string manipulations to parse this apart. So you can define this however. Over here, so I do a time, beginning parentheses, closing parentheses. You can do it that way then. You could pass in that. Based upon what's being passed in, it knows which constructor to run. Since this is just one number being passed in, it comes in one number specifically being an integer. It comes over here and it looks, okay, what do we have? This constructor says no parameters, not that one. This constructor says one parameter, and it says that it's an integer. That's it. That's the one we want. So it'll construct it. It'll run this bit of code right here. If I'm over here, and I'm passing this in, and it says, okay, new time, and then it's a string. Comes over here, goes to my first constructor, says, no, there's no parameters there. Comes to my second one, says, okay, there is one parameter, but this one says it's got to be an integer, so it can't be that. Comes down here, says, okay, the name's right, but this one has 3 parameters. Specifically, they're all integers, so it can't be that. And then it hits this one. And it says, whoa, here's one that has a string as only one parameter, and it's a string, which would happen to match this. Since we put quotes around it, that's what makes it a string. Does that make sense on how a constructor decides which one to use? Okay. Now, and I don't know how you would do this, but if you wanted to have a constructor where you passed in just the minutes, this doesn't even allow you to do it, or is already defined. See how this has one parameter already and it's an integer? One parameter, and again, it's an integer. Since they're both integers, if it allowed you to create the instance, it wouldn't know which one to use. I've never had a need to declare a constructor that has the exact same parameters, like integer, 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 integer. They've always been different. Let's see. This talks about what happens when you declare your class variable names the same as your parameter. You have to use this. We already talked about that. Once you get the hang of it, writing constructor gets boring. You can write it quickly, just like you've seen. It says some facts, some IDs, generate them for you. I don't think I've ever seen that. Probably didn't know where to look in the right place. And this shows you where we have 2 constructors. Now, gets and sets. Problem with declaring these as private is you cannot access them directly. So there's no way to set them outside of the constructor. If I call the constructor where I'm passing in the values for hours, minutes, and seconds, that will obviously set those with these. But if I'm outside of that wanting to change hour, minute, and second, then I can't. Yeah, they're hard coded. Once I create the instance, it's done. And that's what we're talking about the getters and setters. And this is how you do it: get hour, get minute, get second. It's actually whatever you want to call it, but just by a standard programming convention, if you're going to get a attribute, get a class attribute, get a class variable, you do get and then whatever the name is. Okay, so we want to get hour. So I come down here. Actually, I'll leave that one there. It's public because I need to access it outside of this class, and I want to get hour. Now we're not passing any parameters in, and all it's going to do is return this dot hour, and I forgot to put integer in there. You need to tell what variable type you're returning. I want to get minute. And all it's going to do is return this dot minute. And then I want to return, it's going to be a double though. I'm going to return the seconds. So get second. And return this dot second. You don't have to have one line of code in here like this. You could have 100 lines of code. So this get could be very intensive on what it does. You also, and by the way, again, this isn't just a convention. It's not a required. If you want to do a G second, that'll work just fine. If you want to call it David's world, that works just fine. But from a programming convention, it makes more sense if you always name them get and then whatever the class variable is. Because then you know exactly what it's called. Now, usually set is the same way. So if I want to set the hour, I do public void set hour. And I'll pass in hour. And I say this dot hour is equal to hour. So we're not returning anything. We're just calling it set hour. And we're passing in a variable for the hour. And then we're setting it equal to our class variable. And following the same kind of convention, you would have the same thing for all of your other ones. Get minute. int minute. This dot minute is equal to minute. This is the proper design. It says the sloppy way I was showing you is you have gets and sets for every class variable. Public void set second. This would be a double seconds that I'm passing in. And this dot second is equal to second. That makes sense on the gets and sets? So then over here, after I create my instance, and let me just get rid of that and go with this constructor. Now I can do a T dot, and you'll see there's now a set hour. So I can set the hour to 10 o'clock. I can do a T dot set minute. And I set that to 30. And T dot set second. Set that to 45 seconds. To retrieve these values, I just do a get. So if I wanted to write something out to a text field, I could refer to as t.get. Here's just what I was just saying with the set values. These methods are formally called mutators because they change, but more commonly known as setters. I don't think I've ever heard of setters. Mutators is what you usually hear. So that set something. It's probably not a bad stopping place right there. We're not going to get all the way through chapter 11. So next time we're going to continue 11.5. There won't be any assignment out of this yet. Once we finish this, I'll give you another assignment on objects. Is there any questions on any of that? Yeah. Once objects clicks with you, they're so easy. But before they click with you, they're a little bit challenging. I'll go ahead and stop the recording.